All right. I think we should start now. Let me share my screen. We should start now. Let me share my screen. We should start now. Let me share my screen. We should start now. Okay, please confirm if you can see my screen. Starting right away. Just drop a chat in the chat window if you can see my screen. Meanwhile, feel free to drop messages in the WhatsApp group for those who are yet to join to join. You can see my screen, drop a message. We are going away. All right, great. So welcome again, everyone. It's a pleasure to have you back on this call, FREEEE training for data science. This is course 3. This is the third course in this series. We have successfully looked at a couple of things already. Fundamentally, we have been able to appraise R generally, and then we have looked at the type of data structures that we have. We have looked at a couple of things, before now. So let me see which of my screens am I even sharing right now? I think I'm sharing the wrong screen. Let's hold on, guys. Let me share my screen. The network is not friendly tonight, but I'll try to ensure we get the right thing here. So again, I hope my screen is visible. Yeah, it should be. Oh, okay. Just a last confirmation, please. I don't want us to miss out on anything. Okay, thank you very much. But Kazim. Right, so I am currently showing my R. So we looked at a couple of things yesterday. We looked at how to dissect data structures, the different data structures in R, starting with vectors. And we considered the example of a price, which is a vector of 4 numbers. And I told us that if we are slicing or trying to look for any of the data inside, showed you how to dissect that, all right, using the positional argument. For example, 30 in this example is in position 1, and then 34 is in position 2, and so on and so forth, all right? And here, what we did here was to add another element to this vector by doing this. Essentially, you're saying what is there already, which is the price. I'm adding 10 to it. Okay. All right. And then you went further to, with some conditions. I want only the prices that are greater than 30 to show. All right. And if you are to perform any operation on using the elements inside, this is how you index or address the elements that are inside. The first one, price, square bracket, 1, 2, and 3, and so on and so forth. So we went further to look at matrices. If you're creating a matrix, you use the matrix function. And this is the matrix you're creating, numbers 1 to 6. How do you want them to be arranged? 2 rows, 3 columns. And when you run that, you of course know what that gave you yesterday. If you were not in yesterday's class, go back and look at it. We looked at this in line 36 here, how to index a particular number in the matrix. So this means the first row and the second column. What is the number in the first row and the second column? That will give you mat 1, 2. You can actually also get the row sums, meaning the sum of the elements in each row. This will give you a vector of row sums. You can also do the same thing for column sums. This will give you a vector of column sums. All right. So next, we looked at transposing a matrix. And we said if you are transposing a matrix, you are essentially making the rows the columns now. All right. The first row being the first column, the second row being the second column. I went further to say if you transpose the matrix, it takes you back to the original matrix. Now, that's were the things we looked at yesterday. We went further to look at data frame. You can create a data frame like this. Name is John and Shade. Age is 25 and 31. All right. So you can access the information in the age column by using df $age. You can even decide to add another column by doing this. df $height, and then you supply the information in the for the height column. You can perform other operations by saying, okay, I want to subset this data frame by looking, this is the condition for the subset. I want to subset by height greater than 5. All right. I want to subset by height greater than 5. All right. So we move further to look at merging data frame. You can actually merge 2 data frames. We consider that. And yep. So we went further to look at list. In list, you can have a list like this. I told you that for those who are familiar with Python in a way, the list you are seeing here is actually this is a dictionary in Python, okay? But here we're having it in this form. It can actually be, you can even remove the name, the GPA, column name. You can just have it as John in quotes. You can have 3.5, another value, and then you can have the grades the way they are. Okay. So if you're looking for the name John, you will index it as my list, which is the name of the list here, $, the name. All right. This will return to you, John. Let's run that quickly and see how good that is. So that is the entire list. So if I run this, it gives me John. As you can see, if I run this, that gives me the GPA 3.5. And if I'm looking for, this is a vector inside of a list, okay? So the vector name is grades. So if I'm looking for everything in grades, I just go with my list grades, okay? But this is another method of indexing. The 2 up here is called name indexing using $. Then the column, identifier. In this case, the column identifier for John here is name. The column identifier for the GPA value here is GPA. And if I were to do the third one, which we did yesterday, that would be grades. But here we are showing you another example of how you can index, all right, using square bracket and the position of the element. So John, this name here is in position number 1. GPA is in position number 2, as you can see, and then grades is in position number 3. Okay, so if I'm indexing grades, that is double bracket, take note of that, double bracket 3, that will give me everything. If I highlight this only and run without the 2 parts, it will give me 90, 80, 95. All right. But if I'm going to index the 80 itself, that will be another square bracket. Then 80 is in position number 2. And this entire thing will give me an 80. Okay. So that was where we stopped. Okay. I think, yeah, we also looked at operators. We looked at all of this. So today we are going further to do some little bit of further cross check in data structures. Now this is very important because most of the time you are actually going to be working with data that would need data that will be in form of these data structures. The data you'll be working with will either be in form of a vector, will either be in form of a list, will either be in form of a data frame, and so on and so forth. And even if you're working with, let's say, image data is in somewhat a matrix data, multi-dimensional matrix, data. All right. So in one way or the other, knowing how to manipulate this data will give you an edge. And that is why emphasize on data structures and how to index and subset them. All right. So we will go further on this today, and then by the end of today, we will also have we will also be touching a couple of what I'll call visualizations. We'll look at a couple of visualizations today. Okay. So yeah, that's how today is going to go. So let's look at more indexing today. So let's start with vector. I won't take much time here, but let's go. So let's say we have a vector called x, and x is equal to 1, 3, 5, 7. All right. Of course, this is very simple. If you want to index the first element there, the first element 1, you will just say x square bracket 1. That will give you 1. If I run that expressly, that will give me. Okay, the reason why this is saying this is because I am yet to run line 123. I'm yet to run the object itself. So once I run the object, this one will now work. That is 1 for you. All right. If I am indexing the last element, I will say x square bracket 1, 2, 3, 4. All right. That gives me 7. In Python, if I want to check the last element, there is always this -1. That means from the back. Let me see if this will work. Okay, so this is a different thing. I mean, this time around, if I'm saying index, x -1, what am I essentially saying in R is that show me x without the first element. Show me x without the first element. That is the meaning of this. All right. But whereas in Python, if you are doing this in Python, you are indexing the last element in Python. That is what this means in Python. Now you're beginning to see the difference for those of you that are used to, Python. Okay. All right. So let's go further. So let's say I want to index. Take note of this. Now we are getting it's getting a little bit more, complex somewhat. So let's say I want to index the first and the third element. The first and the third element. How do I index that? Take note of this. I'll do x square bracket. All right. I will do this. The first element 1, comma the third element. This will go and get me the first element and the third element. Take note of what we did here. This C is to combine what is inside the bracket. If it were to be a single thing, I don't need the C. Remember, the C is for combine, means for combine. All right, so if I run this, this will give me the first element and the third element, 5. I hope that makes sense. All right, so the next thing we are going to look at is we want to look at, let's say we are looking for elements greater than 3, the same way, X, this. So we will say X, any value in X that is greater than 3. Right? If we run this, that gives us 5 and 7. Take note of all of this because they are very, very important. They are very, 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 very important. Okay, so let's go and do a few yet again on lists. I know we looked at this very exhaustively yesterday, but let's say there is a list called M, okay, or M lists. Let's call it M lists. M list, when you are creating a list, you start with the word list, okay, and then A in this list equals to 1, B equals to 2, and C equals to 5. Correct? So you run it, remember to run it. Once you, okay, it's telling me that A is not found. That was because I use A minus 1. That should be equal to not minus. Now it should run. Good. So if I am looking for the first element, I will say M list. In a list is double square bracket. Take note of that. The first element is the first element 1. When I run this, that gives me value 1. Okay. If I'm looking for the third element 3, that will give me what there? That's not giving me 3. That's giving me 5. The third element is 5. All right. Good. So another way of indexing, like we mentioned yesterday, if we have M lists, we also use the dollar sign. But when you use the dollar sign, you'll be referencing with the name. And the name here is A. The name in the second element is B. The name is C. So name referencing, you use the representative. Let's reference 5 now. 5 will give us a C. And if we run that, that will give me a 5. Okay? All right, very good. So let's go and check more on matrix. Matrices. So let's say we have a matrix, let's call it maths. Creating the matrix with matrix. Repeating this will help you to get a fuller grasp of the whole concept. This time around, we are creating a 3 by 3 matrix, 1 to 9. All right. Remember, it is n row, number of row, which is equals to 3, 3 by 3 matrix. Number of column, in our case, it is also 3. To run this, you have just created a matrix. All right. You have just created a matrix. So let's see how we can index the first element of the matrix. Oh, sorry, the element in the first row and second column. Remember, the name of the matrix first, which is met, square bracket, element in the first row, 1, element in the second column, 2. The first argument you give here is a row argument, and the second is a column argument. What element is this? Let us run our matrix itself so that we can have something to refer to. Beautiful. So, before running this, you can already see the matrix we are referring to now. So, if we are looking for the first element, the element in the first row and second column, first row, second column, that should be 4, right? Let's see what our matrix this gives us. That is 4. All right. But let me ask you, give your answer in the chat very quickly. If I type this, or let me say, let's do this. If I type this, comma, and that's all I type. What is it going to give me? What is this going to give me? Send your answers in the chat right now. I want to see your answers. Send your answers, your responses in the chat. Send your responses in the chat. I want to see your responses. For those of you who are following, no, it's not going to give an error, royalty. If you had attempted it, by now you will have gotten an answer. Okay, Abba Kasim says 1. Okay, good. Anyone else who is trying? 4 and 7. Good, 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 good. I don't want to guess. Try it and give me your answer. Let me go back to the code while you are dropping your answers. If I do just 1 comma, that's all. 1 comma. What does it give me? 1 comma. That means first row, all the columns. That's the meaning of that. First row, all the columns. What do you get? What is your answer there, guys? All elements in the first row. Okay. Someone says it gives 4 and 7. Did you try it out? Did you get 4 and 7? Okay, let's not waste much of our time. So Joshua Oni, you were absolutely right. So when you do 1 comma and nothing after that, you are asking for every element in the first row. Every element in the first row will give us 1, 4, 7. The same way, if I repeat this for the column side, all right, I just put a comma and then I say, let's say 2. What will this give me? Now somebody should give me an answer to that. I want all the answers rushing in. I want all the answers rushing in right now. Yes, we did it in the last time, I think. So let all the answers come in. If I do maths, square bracket, comma, 2, what does that give me? 4, 5, 6. 4, 5, 6. 4, 5, 6. Interesting. That is correct. 4, 5, 6 it is. Beautiful. So I'm confident now that we understand matrix indexing. If you want to get the entire row and the entire column, you know what to do. You know what to do. So we are going to check out, I think we should go to but before we do that, we will look at an example of data frame and see how we can aggregate and group. Questions coming in. Let's see that. Oh, great, great, great. Beautiful answers. Correct. Everyone there is correct. So let's look at what we have here. Let's look at what we've got here. We want to look at data frame yet again. So I'm just quickly going to copy from my second screen right now. Let's see how we can aggregate some data frame. All right. So if this is a data frame with ID, group, and we, all right, 1, 2, 3, 4. 1, 2, 3. That, so there are 4 different entries in this data frame. All right. Let's see how this will look. Let's run it. Let's run it, guys. So if you run this, it's run. If you want to call it, you either type df and run, or you just highlight it and click on run. So this is the data frame, friends. This is the data frame. So let's try and do something on this data frame. Let's aggregate. So what is aggregate? You want to collapse some values that have some similarities. For example, there is a similarity. There is a group similarity. There are A's and there are B's, right? So I can decide to collapse together all the A's and all the B's using a particular operation. Maybe I want to, let's say A's are a particular class and B actually is another class. Let's say A is SS1 and then B is SS2, right? So if I want to get the average of the class in terms of average score of the class, I can use this particular operation I'm about to show you. So it is called aggregate. It's already here. Aggregate. So what are you putting in aggregate, as it were? Now, inside this data frame, there is the ID column, there's a group column, there's a value column. Which of the columns do I want to aggregate? I want to aggregate the value column. Take note of that. All right. I want to aggregate the value column. I want to aggregate, I want to aggregate the value, which is the number that I'm actually able to aggregate. Against, there's a sign there you may not be familiar with on your keyboard. This sign is beside number 1 on your keyboard. Beside number 1 on your keyboard. Look at what I just typed now. All right. I've forgotten just now. I use it very frequently, but I've forgotten the name of this sign. But check it. It's beside number 1, to the left of number 1. You need a shift to access this sign. All right. So it looks like how do you call it now? More like an S, sleeping. All right. So I'm aggregating value against group. I'm aggregating value against group. The next thing you supply here is the data frame on which you are doing this. Data frame. And what mathematical operation do you want to use to aggregate? All right. What mathematical operation do you want to use so that I can return a single value for the common element? I want to use mean. I want to use mean to aggregate. So let's read this line of very simple. You only need to be familiar with what is happening here. All right. So this is a data frame that we're aggregating on. The operation for aggregation is mean operation. All right. So what am I aggregating? I'm aggregating value against group. If you look at the table down here, I'm aggregating value against group. All right. You already know what this will bring. This will give us just 2 entries when we run this code now. It's going to give us A, but at the value side, what you will have happen here is that 1 plus 3 divided by 2, because there are 2 A's here. That means what is the average of 1 and 3 for the A? If A were to be more than 2, the same operation will be performed. You count all the values together. You use that to divide in, right? So let's run this line of code and see what result we get, friends. You see that? That gives you 2 and 6. I've been able to aggregate this. So if you have a whole lump of data, let's say you have a spreadsheet. You're a teacher, and then you have a spreadsheet containing courses, containing a spreadsheet that has information about all the students in the school, all the courses, all the classes. You can aggregate based on different parameters and based on different groups. Okay, always remember that. Good. So let's say we want to aggregate based on 2 different columns. That is also possible. We can aggregate based on 2 different columns. Let's say I want to aggregate, all right? I want to aggregate value against columns group. And I'm using a plus sign now. Columns groups and column ID. All right. Remember, you put in the data frame you're aggregating on, but this time around, I'm using sum. group and column ID. I don't know what difference this will have, if there will be much difference, but this is just to tell you that you can have multiple aggregation. Let's see this. Let's see what it brings out. I'm aggregating value over group plus ID. There hasn't been any change, has there? No, there hasn't been any change, and that is the reason is because the ID has unique values. Okay, the ID side has unique values. That's the reason why we are not getting anything different. And let me tell you how this becomes important. Now, for those who are in Nigeria on this call, you know, in Nigeria we have country, we have state, and then we also have country, we have state, we have local government. Let's say you have a data that has the population data. All right, so in a particular column you are having local government, in another column you are having state, okay, in another column you are having the country, of course, the country. So if you are aggregating the population, the column where you have population, as against any of this, all right, for the local government that is repeating, for the state that is repeating itself for different local governments, if you choose the state and the local government here as group plus ID, that means state plus local government, and then you aggregate, you are going to get aggregated value for states. And if you include the country, you're going to get the aggregated value for the country, whether you are using a sum or you are using a mean. All right. So please take note of that, how this is important. You can aggregate more than one based on more than one field. All right. So we are moving on gradually. We are moving on to visualization. We are moving on to visualization. All right. So let me clear this. If you want to clear what you have here, just click on this broom icon towards this side. Click on it. It will clear what you have in your console. All right. Okay, so let's move to visualization. You start seeing some beautiful things now. Visualization. Visualization. Before we get into visualization, do we have anyone with questions?
Yes, sir.
Yes, please.
Yes, sir. Okay,
Tell me your
on
name,
the
please.
area of the Udi Morima is my name.
Okay.
Yeah, on the area of the aggregate data frame, I entered it the same way you entered, but it was telling me could not find the aggregate data, so I couldn't really pick everything. I don't know if I should snap and send so you see what I did.
Okay. Snap it and drop it in the chat. Let's see. Someone else is having an error. What is the error here? This is not clear. This is not clear. I don't know if you typed it very well. Copy the error path and paste instead of sending an image, please. Copy the error path and send instead of the image.
No, I'm using phone to be online while I'm working with my laptop, so I might not be able to copy directly like that.
Okay. Apart from sum and mean, what else can be aggregated? Okay, what else can you aggregate on? So you can aggregate standard, you can do standard deviation, all kinds of statistical measures, essentially. I mean, basically, different statistical measures. You can do standard deviation, you can do median, all right? So you can actually perform all other, statistical measures, okay? I hope that is okay, Joshua. All right. Any other, error? Any other error, please drop it now. Let's use the next 2 minutes. While I am waiting for some of those errors to be pasted, let me check WhatsApp. I don't want to refer to WhatsApp, but if you are having issues, you can also drop on WhatsApp. Grab my phone and see if I can help using WhatsApp. Okay, so data science is, as we speak today, one of the most sought after. Data science is one of the most sought after skills for many who are actually planning on relocating, especially to the US, to Canada. Do your own finding on the internet and see how lucrative this particular course is. All right. Okay. Met is equals to matrix 1 to 9, number of row 3. So you need to run this line of code first. After you have run this line of code, then you can now start indexing. All right. You have to run the line of code first. Misaki Wande Femi, if you're having errors, you have to run the line of code first. After that, you will now start indexing. That line gave you an error. That's very unlikely. Is there anything you missed there? Okay, math, matrix. That is exactly how it should be, if I'm not mistaken. For the matrix, n row, n column, that is how it should be basically. Except I need to search, look for what the error is. 1 to 9, number of row is 3, number of column is 3. Okay, run it again, please. Get that line of code. Don't just select the math, okay? Put your cursor at the back of math or anywhere on that line and go up and click on run. Do that. Let's see. Do that and let's see. Okay. Sorry, this thing you pasted here is not actually showing very well. I can't see it. Mine gave this, but it was not coming out in matrix form. But this is not a matrix. This is a data frame. Oluwase Bankole. This, what you just pasted here, aggregate data frame. Are you having error with this too, Oluwase Bankole? Because this is a different thing entirely. This is not a matrix. This is a data frame, okay? So when you run this, this will give you a data frame. When you run the DF to give you a data frame. As you can see, we are creating the data frame here. Okay, unmute yourself and talk, Bankole. Let me hear exactly what you're going to, what the problem is.
Can you hear me, please?
Quickly, so that we can move. Yes, please, Bankole.
Okay, when you ran this data, it came out as AAA BB1357, but mine came out just this way, so it wasn't arranged.
Okay, take note of this. Take note of this. You open the brackets, but you did not close with the last bracket. There should be a last closing bracket.
Yeah, so I forgot to copy it straight, but the last bracket was there.
Okay, so now what you just did was that you just created the data frame. Now go to the next line and type DF and run DF. DF has been created as a data frame object. Go to the next line and type DF and run DF. It will now show you the data frame is full. What you run was the code. Yeah.
Yes, so, I got it now. Thank you.
Good. So, Akiwande Femi, are you having the same issue? If you typed math this, it's going to give you exactly the same thing when you run it, sure. But if you want it to show the matrix itself, type math on a separate line and then run that math.
So
First
sorry,
thing was to assign to an.
Sorry, I didn't get that. When I run it, it keeps giving me this information I posted. Initially, it was giving me. Okay.
It's okay. It's okay. So that's what you are expected to get. All right.
Oh, okay.
Now type math. The first thing you did here was to create the objects. The assigning of operation there, the back arrow. So math as an object has been created. Now you need to type that math and run that math before you see the data frame. Before you see the matrix itself. Type math on a separate line and run.
Okay.
Type math.
Oh, okay. Okay. I've gotten it. It has worked. I have a result now.
And run. That should give you what you're looking for. Correct?
Yes, I have a result now. Yes.
Beautiful. So you can now do all the operations that we did earlier for the subsetting and the rest. Is that fine?
Right.
Good.
Yes.
Beautiful.
Yes, that's fine.
Beautiful. So no matter how big the matrix is, these operations will fly for any size of matrix. Good. Remember always, guys, when you run a code that is assigning, don't expect to see the result, but the object will be created, because what you did was that you assigned what is at the right hand side to the left. Until you call that object, you may not see anything, whereas something has actually happened. Okay, you'll see that object created in your environment side at your top right. Is that okay? So now we are going straight into data visualization. If all those errors are clear, please, I want you to pay attention to this. Before I say this, we were mentioning, just before I started answering these questions, that data science is a sought after course. Take some time out and do some digging. You'll realize how important it is. And no one cares about your degree, whether you have a master's or you are a PhD, you are an undergraduate. If you are able to prove your substance that you can do this, you can manage this data, you can you can generate sense from data, you'll get the job. All right. So it's not about your certificate. In case you have a certificate that is not giving you a job, you pay attention to this, you do personal study, you pay attention to all these rudiments and fundamentals they were giving you in this course, you'll be able to take up, data science roles. However, you need to get your hands toughened, all right, from high-level task before you get to that step. But this, I tell you, it's the beginning you will ever get as far as data science is concerned. There are two major softwares for data science. R, which is a general purpose programming language, which functions very well in the domain of data science. And then R, the first one, Python, which is a general purpose programming language. And the second is R. R is specifically for data science and statisticians. All right. So you will never be wrong saying you're focusing on R. You can even connect R to your data pipeline. If you are a data engineer, connect it to your AWS and do all kinds of analysis right there on the fly. All right. So you are here for a treat. That I can tell you. That I can assure you. All right, so let's move ahead. We are going into visualization. It's always very interesting. All right, so we are going to check a particular data that we are going to be using for this course. And the data is what you call empty cars. The data is the data you call empty cars. Empty cars. Let's see what this data is about. So this data is about different car brands. You are getting close to real life data now. This data is about different car brands with, you know, their different information. For example, Mazda RX-4. This MPG is mile per gallon. Okay. The number of cylinders. I need to check out this. So let's start digging into how to get information in R Studio. So if I want to get more information about these empty cars, I'll come to this console area. Take note. I'll come to the console area and type question mark. All right, question mark, and then empty cars. The same thing if you are looking for more information about a package. You don't really know what the package is doing or whatever, so you come here. So I want more information about empty cars. I just typed it, empty cars, and a wealth of information is showing right here at the, right here. So this is empty cars. The data was extracted in 1974 from Motor Trends US magazine, or empty cars. Now this is what all these columns stand for. The MPG is miles per gallon. The this CYL is number of cylinders, displacement, gross horsepower, rear axle ratio, all right, weight of the vehicle, quarter mile time, some of you are not into the column, that they represent. Is that okay? So we are moving ahead. Let's bring this back so that we can have our windows. So this is a particular data set. This is a data set. It's inbuilt. You don't need to install any package to have it. It's a base data set that comes with R. All right. So the first visualization we want to do is a histogram. A histogram. So how does a histogram look? How does a histogram look? I think a histogram are bar charts that are closely packed together, if I'm right. Histograms are bar charts that are closely packed together. Histograms should be bar charts that are closely packed together. And that is the first visualization we are going to consider. Okay, so let's come back here. So how do you perform? How do you do represent a histogram in R? How do you represent an histogram in R? So let's do a histogram of empty cars for the miles per gallon, the first column here, I think. The first column, this moment. The first column is MPG, okay? So let's do a histogram, HIST. That is histogram for you, not the complete word. Histogram, I want to see the histogram of a particular column. Now, what the histogram does, let me just explain for those who are not too familiar with statistics. Histogram tries to show you how the distribution of your data, right? Let's say in a class of primary 6, I want to plot the histogram of their age. I just want to see at a glance the distribution of the age. Do we have more people below? Do we have more people below 8 years in that class? Right? Or do we have more people above 9 years in that class? They distributed such that they are almost of equal age range. So empty cars, I'm considering the MPG, remember? So I would say dollar. That is how you reference the column MPG. All right. If I run this, it's going to give me, see the way I'm collapsing this side because something might spin up here right now. So if I run this, it's going to give me the histogram of the MPG. Let's run this. Good. Now I have the histogram of MPG. This is it. This is the distribution, friends. Okay, this is how the values are distributed. As you can see here, so we have more values within the range of 15 and 20. More values within the range of 15 and 20. You can see 18, you can see 18, you can see 17, 16, 17, 15 to 15, 5. So we have more values within that range, obviously, that we can see, followed by within the range of 20 and 25. Okay, so we have just successfully plotted a histogram. Now, this is not the only visualization we have in statistics. We also have other visualizations. We are going to look at about 4 of them today, or more as time will permit us. So the next one we want to look at is box plot. Is box plot. Now, box plot is a little bit, technical kind of visualization, but I will try as much as possible to explain it to you when I'm not plotting. So let's do box plot, still from this data. Box plot from this data. If you need more explanation on any of this, try to do some Google search. So how we plot box plot is actually using the word box plots, right? Box plot. So when you are plotting box plot, okay, we are using a new, I think we should use the new data for this. Use the new data for this. There's another data let's see this particular data. This data is called tooth growth. This should be let's see what this data looks like. Tooth growth. Okay. Length. This should be a medical data, but let's see. Let's read about growth. Okay. Okay, the response is the length of odontoblast cells responsible for tooth growth in 60 guinea pigs. All right. So what are the columns? Length, numeric tooth length. Okay. Subfactor, the supplement type that is given to them, either a VC supplement or OJ supplement, and then dose, numeric dose in milligrams per day. Okay, now we understand what this data is for now. All right. Okay, good. So we are going to use this data to do a box plot. All right. So what columns are we using? We are using the length column against, look at what I'm using as against here. I'm sure you were able to find this symbol. It's beside 1, to the left of number 1. You use a shift to access it. I'm doing length against those. Length against those. Of course, you have to provide what data you are referring to. The data is tooth growth. That is tooth growth. So let's see. Let's run this. Let's see the results. Okay, so you have basically 3 types of doses here. You have 3 types of doses here, and these 3 types of doses, you have this box plot for them. Let's zoom and make this bigger. I don't know if you can see this. So now, what does this mean for box plot? This is also showing us how our data is distributed, right? Thick line, this thick line you see in the middle, actually the mean of the data. Okay, there is something you call first quartile in statistics. first quartile in statistics. All right, more like the minimum value. Okay, this is the minimum value. The lowest line here is the minimum value. This box here, the down part of this box is the first quartile. The second, the thick line in the middle is the second quartile. Another word for second quartile is another word for the mean is 50% percentile, something like that, 50 percentile. And then on top of that, this particular one is what you call the upper quartile, or is it the third quartile? I think it's the upper quartile. I can't remember now. And then you have this is more like an outlier. Okay, so the upper part here and the lowest part here, these two are outlier. The majority of the data fall between this box. Okay, so you normally use box plots to know, okay, how is this data behaving? Do we have so much outlier, or we have outliers and not so many? All right, but the major distribution is within the box. So that is the key about box plot. Okay, you understand the real data, how the data behaves exactly. Okay, so we have looked at box plot. Let us consider another plot that is always very common in the real world of data visualization. This particular plot is very, very common. It is called scatter plot. Scatter plot. So we are going to plot two things. We are going to the empty cars. We're using the empty cars for this particular plot. Let me close this. Sorry. Let's do this. All right. So we are using the weight, the WT, and the miles per gallon column. All right. We are plotting the weight against the mile per gallon. And follow me as we go on. When you're doing scatter plot, you use single word plots. What you use is just plot. And you give the X and the Y. Let's go. Empty cars. First one we are using is the weight, which is our X. And the empty cars, the second one is the MPG, remember? You don't need to specify the data since you are referencing it right here. Okay, so in RStudio, if you want to move what you're typing to the next line, after the comma, you can press an enter. It's a continuation of the code. As you can see that the bracket is still there waiting for you. So let's give our chart a name, call that main, put this in code. All right, so let's call this scatter plot example. When you're done with that, you can just give let's do another thing. Let's give the label to our x-axis. You use xlab that, sorry, weight. Okay, so the next thing you are doing is your y label. Y label is equal to PG, miles per gallon, right? We are done right here. So let's run this code. If we run it, let me push this here so that we can see the box plot. So when you run this, you get a box plot. Sorry, a scatter plot. I beg your pardon. A scatter plot here. As you can see, this is the weight against the miles per gallon. Are you seeing something here? The more the weight, the lower the miles per gallon. The more the weight, the lower the miles per gallon, as you can see. So it's kind of inversely proportional. If I were to draw a line here right now, if I were to draw a line, a trend line on this data, you are beginning to make sense out of data now. All right. So if this data just comes to you and you are wondering what is it about, and you say, okay, let me have a scatter plot of this data, and you have this in front of you, the meaning you draw out of this is that as the mile per gallon is increasing, the weight is reducing. That means the more the weight, less the mile per gallon. That means heavier cars will not run faster, all right, than lighter cars. I hope I'm right by that interpretation of this particular plot. Okay, all right. So, do we have any question at this point? I'm going into real data science right now. Do we have any question at this point? Arrow does not need to be online before it works. This data set that we are using, they are inbuilt with R. You don't need to be online. So even if you have no internet, you can still work. Don't worry. When we get there, you will be able to assign colors to Instagram. Histogram. Sorry, and we'll do a couple of other beautiful things. And at the end of this particular 1 month course, we are going to be organizing a masterclass, but that is only for those who are interested. After this course, you really don't need any other thing except for personal practice. But if you are interested in engaging with real world projects, big projects that we will be able to run together, then you can hop on the masterclass when that time comes. So we are going to be doing cool stuff in that masterclass if you are interested when that time comes. So for now, just hold on. When we get to coloring of our Instagram, I'll show you how to do that. Beautiful. Okay, so let's go back to what we are working on. This is the scatter plot. Okay, so let's see. Let's look at something else right now. Okay, so we are going to let's have a few more. Let's say we are having let's do a line graph. Let's do a line graph. So just a moment. I want to see if I can try another data set here. Just a moment, please, guys. I'm trying to check if I have another data set available on my second machine to try out and see what happens. Okay, let's still use the empty car data set. All right. So we are going to use the empty car data set. So we are doing a line graph. We're doing a line graph. So we are going to be plotting. If you're plotting a line graph, you use the word plot. All right. We are plotting pressure, and should be a data on its own. Should be a separate data. Should be a separate data. But let's go ahead. So the type of it is a line, just an L there. Now we're introducing some color. The color is blue. There are other codings, there are other ways of representing it. And when you see the word main here, you're talking about the title of the map, okay? Line graph example. Okay, so let's run this and see what results runs out. There's an error here. Could not find the function plot. Do I need to load something that I don't have already in this system? Let's see. Oh, am I using a capital P here or a small letter P? Oh, I think I just used a capital P just now. Oh, so sorry about that. I use a capital P. Remember, R is case sensitive, so it's a small letter P. Always small letter for all your functions. Okay, so this is it. Pressure against temperature. Pressure against temperature. You have it there, guys. Okay, so I think this pressure is just inside this R pack. I mean, it's just a data inside, you know, inside here. Okay, so don't just bother about that. But whenever you need to plot this, just remember. Let me even see. Let's see. Let's see what this how this data is. Okay, so there's a data called pressure. Okay, the name of the data is pressure. All right, so if you want to plot the particular temperature, you can just plot pressure dollar temperature. All right, and then you're plotting it against the index. The index is the first value here, the 1, 2, 3, up and down. Okay, good. So let's move ahead. So the next, we are discovering new things here. There's something else you call heat map to look a little bit more beautiful. Heat map. So we are designing a heat map. A heat map has to do with correlation. This is a new word for many who are on this call. When you say correlation, your height most times correlates with the size of your shoe. So what I mean by that is tall people will most likely wear, you know, is it bigger now? Bigger sizes of shoes. Tall, there is a correlation there. The same way you will not expect a baby to wear size 30 shoes because the baby is a baby anyways and the legs are small. So there is a correlation. That means when you are looking at this particular variable or this particular quantity, you can infer what the other quantity will be. So there can be positive correlation and there can be what? Negative correlation. Take note of that. There can be positive correlation, there can be negative correlation. So in this case, if we are creating a heat map, you'll see how that looks now. Heat map helps us to see the correlation among the elements in a particular data. So if we are creating a heat map, you will just say correlation of empty cars. All right, that's all. But we need to constrain some values. Row value. Okay, this is some of the things you must give as far as heat map is concerned, and then column value and a. All right, so let's run this and see what result it gives us. Good. So where the stuff is darker, there are very high correlation there, and where it is lighter, there are very low correlation there. All right, Of course, you can see that weight is perfectly correlated with weight, 100%. So where they are correlating with themselves, you expect it to be 100%, right? Absolutely. And parameters that are not, that are not correlated with each other. For example, we said the other time that there was a particular, let's go back and look at some of the functions that we drew. Okay, this is MPG and weight. This downward line means that it is negatively correlated. Negatively correlated. So let's go back and see MPG and weight. MPG here, and where is weight now? Weight is here. So this is perfect negative correlation is the pure yellow, and then perfect positive correlation is the darker red, as it were. So take note of that. When it is very light, that means there is negative correlation. When it is very, very dark, then there is positive correlation. All right. In between is almost that they are not correlated in any way or form. So you can try a couple of this column yourself by doing the what's it called now? By plotting these scatter plots and see how they correlate. The one that is in the middle among those color gradings, the values will be so scattered. So you can't really draw a relationship between the two parameters. Is that correct? So let's see what else we can jump on today. I think we should take some questions right now. Do we have any questions, guys? So if you have your questions, I'm all ears. Please post your questions. Let's see if you have your questions. Okay, so somebody is getting an error, pressure, temperature, comma. Type is not 1. Type is L, just L. L there means line. You check my code again, it's an L, not a 1. It's an L, sorry. Okay, it looked like a 1. It's an L, okay? Check it out, it's an L. If you have any questions, please post your questions. I'm right here. I'm right here to answer your questions. Please post your questions right here. Let's do this. How can we add R squared to the play? Very good. I know this is a very, very familiar question. Along the way, we will do activities that would give us R squared normally. Okay, but I'll also show you as we go on in this course how to get R squared. For example, in the negative one that is correlated, we can always get an R squared from there. All right, so just keep it, just hold it. We will get an R squared. Okay. Keep your questions coming, please. Okay. And how do we add color? Is this the second question or the one I saw before? Yeah, I said we are going to treat this subsequently, okay? I don't want us to jump it, right? We're still going to do a lot of visualization. So please, let's take one after the other. For the person who is interested in R squared, by the time we get to modeling, all right, R squared comes in statistical modeling. So we'll treat R squared there, all right? So we're still going to look at model. R squared is actually part of the things that are returned when you perform a model. When you carry out modeling in R, linear regression modeling. All right, so we'll see R squared when we get there. So that means in this particular course, you are also going to be modeling data. Okay, you're going to be modeling data. Modeling helps you to predict data sets that are not given to you as part of what you have. Okay. So let's take note of that. We have big stuff coming on the way. There are any other questions? Please drop it before we move ahead. We still have some substantial amount of time, so we are going to go deeper in our visualization journey today, and hopefully by Friday next week we will go. We will try a few things. Try out a few things. Okay, so do we have any more questions? Okay, plots, checkers, main example. Yeah. Do you have any issue with this? Guest? Issue with this? Yes, we can import data into R. My scatter plot does not come. It's supposed to come. Empty cars, wait, comma, empty cars. Was this how we did this scatter plot? Let me see the code again. There might be you might be making there might be an error there. Let's see. Sorry, system is hanging so badly. Okay. Let's see our scatter plot. Okay, empty cars weight, empty cars MPG. It should work. Have you run it? Have you run it? Empty cars, dollar weight, empty cars, dollar MPG. Let's love. It should work, please. Run it. Let's see. Let's see if I can get your error. I'm going to run this exact code that you put here. Let's see that. Maybe I'll get where the error is from. Okay, so I just pasted your code here now. I'm about to run it. Let me look at it again. Empty cars, dollar weight, empty cars, this, MPG, then main, scatter plot example. Let me run this code. It's giving me an error also. Where is this in? Main scatter plot example xlab. Something is not right. Oh, you made a mistake. Remove this quote from before xlab. Remove the code from before xlab. Put it, okay, it's okay now. Remove that code that is before the ylab. Remove the code before ylab. There's a quote there. You made a mistake there. There is a quote before ylab. Remove that quote. ylab is standing alone like xlab, then that solves the problem. Yeah. So remove that that code before ylab. That's the solution to it. After that, it's supposed to run. If I run this now, it should run. Yeah, it runs. Is that okay now? Okay. Let's confirm that one more time. If we have a good... No, you can't say that. Even without it, it's the same error. No, it can't be. Okay, this person is making the similar mistake. No, it can't be. Okay, I just hope it's corrected now. Yeah, okay. Yeah, code that error. All right, so let's move ahead to another level of visualization. We are essentially going to be looking at another kind of data. This is a very popular data in R. It is called the iris dataset. The iris dataset. Iris dataset. Yes, iris. We check it out. Iris datasets. This is it. For those who are into agriculture, it's actually sampling different species of, I think, flower, and then looking at their length, their sepal width, their petal length, and their petal width. All right. So we have it like this. So if you want to check it out, just type question mark here, iris, and like before, you are going to get this particular value here. Edgar Anderson's iris data. You can read more about it. All right. Read more about all the dimension and a few examples there. Okay. When it is time for modeling, we might likely be using the iris dataset for modeling. So I'm just going to copy a portion of the code from my second system for the iris dataset. See how we do that. So we are doing this for scatter plot. We are plotting the sepal length. Let me show you the header of it. Sorry. Sepal length and the sepal width, just the two column here. All right. And let's plot that. This is it. You see this kind of data is not showing you, is not in any direction. So you cannot say that it is positively correlated or negatively correlated. I can tell you that they are not correlated. Okay, that is what you get from that scatter plot. Okay, let's do another one. This time around, we'll do the one for histogram. I want to be fast, so I'll just get the code from my support computer. So this is for histogram. Histogram, we want to get the distribution. How are the values for the sepal length. How are they distributed? Okay, we want to get that, and let's run this. So this is what we get. Okay, they are distributed like this: frequency and the sepal length. So we have the middle values having more of them, and then you know, the ones with less than 5, or the 4s, and then the ones that are higher than, they are not much. So you have most of the flowers between 4.5 and 7. All right, this is the information that the histogram gives you. Is that correct? So the person that was asking the other time how to color a histogram, just include COL in your argument. Include COL and try to get the name of the color. You know, the arrow recognizes things like this: light blue. Let me say blue here and run it again. Let's see the result that it brings. So arrow recognizes a few of these things. This is blue. So we are beginning to color. So let me see if there is a dark blue. If arrow recognizes dark blue, oh, dark blue is here. So your question has been answered. Let's check out something else. There is what you call bar chart. Let's do the first bar chart in this exercise. Before we do bar chart, okay, let's do bar chart. So for bar chart, so remember, bar chart is bar plot. Okay, take note of all these functions. Histogram is HIST. Take note of all this. So for bar charts, we look at what is happening here. There's another function inside, table function. All right, and we have this argument, names argument. These are the different types of species. All right, these are different types of species here. So we are looking at how do they occur. So what this table will do here, take note, what this table will do is that this table will table their occurrences, and then this bar plot will plot it. So let's roll it and see the result. Look at it. So they are almost of equal proportion. If there are 150 values there, let's see, 150 values. The way this data comes, they are almost of equal proportion. And you are giving the color to be rainbow color, meaning that out of rainbow color, pick either the first 3 or any 3, and you have it. So that means if I see, we are learning in the process. If I come here and put this here, histogram, right? Yeah, let's try this. And how many? 1, 2, 3, 4, 5, 6, 7, 8. I say 8. Let's see if it works. I'm not sure, but let's see if it works. Oh, great. Now you can see that. So I'm sure you learned some beautiful things right now. All right. So we are learning from one level, we are transferring it to another. All right. Is there anything? Is someone dropping something? All right. Great. So that's good to know that we are grasping that. All right. So yeah. So let's see what other thing that we can hop on today. We are going to be doing some advanced visualization. This will be the last thing we'll do, and then we'll draw the curtain for today. But before I go into that, if you have any questions right now, please drop your questions right now. If you have any questions, please drop your questions. I'm all ears, because we are going to do something that is a little bit different. Drop your questions. I'll wait for about 2 minutes. for about 2 minutes. Okay. So we are going to another level right now. So we're going to import our first package. If we don't have it right now, we are going to install it and then we'll import it. There's a package called ggplot2. ggplot2. This package is used basically for plotting things. It's used for plotting things. ggplot2. Give me a moment. Let me look at my other system if I have the package. Meantime, you're free to drop your questions, please. I'm trying to I'm trying to look at, search out the package thing, if I have it. So let's do this. Let's try and install it. I'm not sure I have it here. ggplot. Oh, it's actually here. For those of you who don't have it already, you can do install packages, and in quotes you have ggplot2. Okay, and after installing, you will use this to load it. If you don't load it, you can't use it. ggplot2. Is that okay? Because I have it installed already, just watch out, just look at this place. I'm going to run this particular one. Here I'm loading. It's loading. It's not supposed to take time, but I don't know why it's taking time. Okay, it's done. Particular data set I'm looking for. Okay, this data set comes with MPG. All right, great. So we are going to work with this particular data set. If you don't load this library, you will not have access to this data set. Okay, so we are working with the MPG data set. So let's start. Let's start, ladies and gentlemen. We are going to do advanced data visualization. Advanced data visualization. Before we move ahead, up to now, do you have any questions? Because we have just 20 minutes left, so we're going to run through this as quickly as we can. As quickly as we can. So the beautiful thing about ggplot is that you can be adding elements to your visualization as you go on. You can be adding elements to your visualization as you go on. So we are doing with advanced visualization. Advanced visualization. So we want to plot. Now let's inspect the data. We are using this MPG data. MPG. Let's look at the data sets. 4 more rows. So this is the data set. The data set has DSPL. You care, we check it out. NPG. Let's look at oil economy data from 1999 to 2008. Now, these are near real world data, please. That's why you must pay attention to the kind of data we are using. Read more about it. Year of manufacturing, engine displacement. This is more like the empty cars data, all right, but another type of data in fact, but related to the MTK. It has 12 and 34 data entries, 11 different variables. All right, so that is how you know what kind of data you are working with. Very important. All right, even the transmission system is also here, in case you are wondering what kind of transmission system does it have. So we want to plot two things. The DSPL, this DSPL, I forgot what that is. Engine displacement. Okay, we are plotting the engine displacement and the, what is this other one? Highway miles per gallon. HWY, engine displacement and highway miles per gallon. We have inspected the data. So what do? It's ggplot. All right. The other one we use just ordinary plots, right? This is going to be more beautiful than that one. First thing you give it is the data that you are using. The data is the MPG data. All right. Now, look at this function, AES. AES is for aesthetics. AES, what am I plotting? I'm plotting on the x-axis, DISPL. This is how ggplot works. And I'm plotting on the y-axis, HWY. All right. That is supposed to be enough. If I run this, it should give me something, except I must provide some other things. Yeah, these are not enough. Did I type EAS? Come on, it's AES, aesthetics. Let's see if that will give me some plots. Okay, it actually gives me something, but it's not giving me any value, right? Because I have not instructed it on what kind of visualization I want to see. So is it line you want to see? Is it points you want to see? Okay, I want to see points. So after this, you use a plus sign to add other aspects of your visualization to it. So if you want points, what you type is geom point, GEOM. All right, underscore point. So essentially, you will actually need to learn some, packages. All right, by using it or by just copying whatever code you see out there and get used to it. All right, so I'm adding points. In this case, I want the color of my points to be blue. I'll add the parameter of my points to be blue. There is a parameter called alpha. I want that to be 0.5. I want to know what alpha is. When the result comes out, it without including alpha, you'll see how that plays out. And then I'm done with this. This is not enough. I want to add something else. I want to add my labeling. I want to add my custom labeling. So let that be another plus. So how do you add your labeling? Labs. Let's open this up and take it one after the other. My title. Remember, in the former one, in the ordinary, in the base plotting, you use the word main. In this case, you are using title for your labeling. So there is a labeling for title, for X, for Y, and then you can add a caption to it if you want. All right. So for my title, I have fuel efficiency. Let me add that in quote. It has to be in quote. Fuel efficiency versus engine size. All right. Of course, that will be a comma. Let me add the next thing. The first one was X lab. Now it is just an X. So engine displacement, that's my X-axis. displacement. If you have any error here, please let us know. We'll resolve that before we leave tonight. Tonight's class is a big one. Highway miles per gallon. And I want to add a caption to this. Caption. Good. I want to add a caption to this. And the caption is where I got my data from. My data source is MPG dataset. Correct. So am I good to go? Can I run this right now? Let's try and run this. This should run at this stage. Of course, there are other things we can add, but let's run this. Okay, so something is coming out here already. You remember the other time when we ran something similar for the empty cars, we got this this kind of correlation, -1. All right. Yeah. So we are getting something, but we can also add some more beautiful thing to our coloration, to our plots. All right, so let's add something more. We want to customize our axis ticks. So let's customize our axis ticks. Scale X. Scale continuous is supposed to be here. Okay, this is it. Scale S continuous. Thank you. All right, breaks equals to, want a sequence. Two, 6. Let's use a 6 by 1. Remember, I'm putting the plus. I'm adding another scale here. This is for the X. I'm adding another scale for the Y. To ensure I'm not making a mistake here. It appears there is a mistake somewhere. Let me see if I can see that. Scale opening bracket for breaks equal to sequence. There is nothing here. Let's see that again. Good. This is supposed to be here. So please ensure you are not making any mistake. There is a Y. You see how this turns out. Sequence of 10, 40 by 5. Okay, so we can add something else here. This is just telling you that you can do all kinds of things. Like I said, this is an advanced visualization. So I'm adding all of these elements so that you can know that you can actually do a couple of things, okay? Even if we are to run this now, let's see the improvement that we have on our map. An error somewhere. We have to get the error. This should be it. Bum, 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 bum. Is that all? Is that all? Any other error? Any other error? Did we get that correctly? So let's go back to it. And to see if 10, 40, if there has been an improvement here at all. 2, 4, 6, 2, 4, 6, scale of 1, 2 to 6 by 1 by 5. Okay, let's add another visualization to be sure if what we intended is happening. Okay, so let's add what we call theme lights. The theme is light. You can decide to add all of this, or you just do the little thing you have to do. Dot title. Like I said, these are not compulsory. Let me just copy this particular portion and add it. Let me copy from my prep system and add it to you for you guys to just. All of this will be sent to you via the notes. Okay, so let's have this portion. All right, so the theme, the plot title, the element text is 14, face is bold, all of this. And this gives you a background in case you want to do your own work. You have an exhaustive list of what you can add to your map. You can still read more about it. You can still read more about ggplot and see what each of these elements, what they do, okay, on their own. All right, so let's see. We've added so many things, very confusing it might seem, but let's see if there is any, is there an error somewhere? Error in ggplot, can't add these to a plot, to ggplot objects. Which of that, which are we looking at? Did I miss something? Yeah, that's the issue with this thing. Sometimes you might just miss out something you won't know. Let's see. Okay, not much has improved. So we may want to neglect some of these additions. All right, at least up to this portion of the caption, we got some of these additions. So once I'm able to figure out these errors, we might repeat this particular visualization. All right, but in any case, this is what we are able to do with ggplot. As you can see, we are plotting out these visualizations the way we find it. So there are other parts of ggplot that you may want to check out yourself. ggplot 2. You may want to find it out and look at what other visualization can be done. I run this, it should show. All right, so you can create all kinds of visualization. So you can't even get everything here. You need to go to their website, Tidyverse. If you click on this, you go to the website and read more about it. You have a lot of exercises that can guide you on what to do, all the kind of visualizations. So it's from there we were able to get all of these things. Unfortunately, this particular part is not adding up. But once I figure it out, I will include it in the material. If it is not working out still, I will just include the other parts that works. So at this stage, we've come to the end of today's class. If we have any questions, now is the time to answer the question. Your bar chart is not showing. Have you been able to resolve that? Ifeoluwa, have you been able to resolve your bar chart not showing? Let me end the recording here. If you have any questions, let us know.